Hello everyone. In this video, we will be looking at another very simple sorting algorithm called as insertion sort. Now, as compared to previously, we have seen the two sorting algorithms, the bubble sort and selection sort. As compared to these two, the insertion sort is somewhat tricky to understand, but at the end it is also very easy. Okay, at the end it is also very easy. And so let's just first write the algorithm for selection sort, and then I will explain you the dry run, and at the end we will code. Okay, so what is the idea behind insertion sort? The idea is to pick an element pick an element from an unsorted array and put it into correct position, comma, to form an from a sorted array. Perfect. To select an element from an unsorted array, put it into correct position to form a sorted one. Okay, now let's just go stepwise. Okay, so in selection sort, we have seen that we need to play with three variables, right? So similarly here also we need to play with three variables. If you know how to operate these three variables in insertion sort, you can anytime easily code for the insertion sort. And these three variables are I, okay, I, current, and previous. If you know how to operate on these three variables, okay, I, current, and previous, we can anytime easily code for the insertion sort. So step 1, I will move from 1 to array length. Very important. I will move from 1. Okay, index 1. Okay. So in array, as we know, indexing start from 0 to last position. Okay. So remember, I will move from index 1. So this means from second position. Okay, from second position. Okay, from second position. Step 2, step 2, uh, initialize current is equal to ARR of I. Okay, and this happens in outer loop. Step step 3, initialize previous is equal to I minus 1. This is also in outer loop. Now step 4 is a while loop. This is the most critical step, and here in this step you can get easily confused, and so please pay attention. Okay, while loop. Okay, while while previous is greater than or equal to 0 and and array of previous is greater than current. Till this you have to do two operations. Okay, till this you have to do two operations. So the first operation is array of previous plus 1 is equal to array of previous number 1, and of course in any while loop at the end we require a update statement. Okay, previous minus minus. So these two are the major operations which we are doing in the while loop. So actually only this one is the major operation. One is the update statement which we anyways require in any while loop. Okay, and then step 5. So basically this is inner loop. Step 5, in the step 5 array of previous plus 1 is equal to current. This is again in outer loop. Okay, let's just first revise these steps again and then I will show you how the dry run is actually working. Okay, so step 1, I will move from first index to array length. I will move from first index to array length. So when I'm saying first index, it basically means from second position. Step 2, initialize current to ARR of I. Okay, initialize current to ARR of I and initialize previous to I minus 1. Initialize previous to I minus 1. So these three steps in the outer loop. Okay, these three steps in the outer loop. Then as far as inner loop is concerned, we will require a while loop while previous is greater than 0 and ARR of previous is greater than current, and ARR of previous is greater than current. So both these positions must be satisfied. And then inside inner loop, all we are doing is ARR of previous plus 1 is equal to ARR of previous. And lastly, in the outer loop, ARR of previous plus 1 is equal to current. Okay, so I am assuming till now you have understood absolutely nothing. Okay, but no need to worry. It's just I am discussing the steps now. Okay, I am discussing the steps now, and let's now see the dry run for this. Okay, let's now see the dry run for this. Okay, so I think this is very simple. So when I say I will start from first position, so I will be here. Okay, uh, then current is ARR of I. Okay, so current is ARR of I and uh, previous is I minus 1. So previous will be here. This okay. So the names are very big. So let's just write P and C for this. Okay, P and C for this. So C is for current, P is for previous. Okay, and so okay. So we have successfully completed these three steps. So step 1 was that index 1, I will start from first index, that is second position. Current will be at ARR of I. So current is equal to 4 now and previous is equal to I minus 1. Previous will be equal to I minus 1. Okay, perfect. Now we will move to iteration of while loop. So while previous is greater than 0 and ARR of previous is greater than current, let's see if both the conditions are being satisfied. Previous is greater than 0. So currently previous is greater than or equal to 0. So currently if I is 1, then previous is 0. Okay, I is 1 and previous is 0. So yes, this condition is satisfied, greater than or equal to 0, and ARR of previous is greater than current. ARR of previous is 5 and value in current is basically ARR of I. Okay, so value in current is less than previous. Okay, satisfied. So both the conditions are satisfied. So ARR of previous plus 1 means this previous plus 1 means this position is equal to ARR of previous. So what we will do is we will bring 5 here. Okay, and then previous minus minus, so P will move one position behind. Now again we will go and check while loop. So are the both conditions satisfied? So this time you can see this condition is not satisfied because previous has now become -1, that is 0. From 0 it has been decremented to -1. So this loop will break and we will simply come to step 5, and step 5 states that ARR of previous plus 1 becomes current now. Okay, so previous plus 1 is again this, and this becomes current. Now current was having initially ARR of I, which was number 4. So yes, 4 will come here. See, current and previous was here initially. Okay, then I plus plus I will come here. Initialize current to ARR of I, current will come here. Initialize previous to I minus 1, so previous will come here now. Okay, perfect. Now while previous is greater than equal to 0, correct, and ARR of previous is greater than current, so ARR of previous is greater than current. Current is having number 1. Yes, it is. So what we will do? ARR of previous plus 1 is equal to ARR of previous. So basically 5 will come here. Okay, done. And then previous minus minus. So P will come here at first position. Then again check if previous is greater than or equal to 0. Yes, it is. And ARR of previous is greater than current. So 4 is greater than current which was ARR of I 1. Okay, so yes it is. So ARR of previous plus 1, so previous plus 1 is equal to ARR of previous, that is 4, and initially previous minus minus, so P will come here. Okay, now the while loop will break again, and ARR of previous plus 1, that is again here, will be equal to current, so 1. Okay, so as you can see, this is a little bit tricky to understand. This is a little bit tricky to understand, but pay attention what is happening. Actually what you are doing is you are you are first placing I at a particular position. Okay, you are placing I at a particular position, and you are iterating backwards. And you are checking, and you are basically checking if the elements are greater than current element, and if yes, you are first shifting all elements by one position forward. If yes, you are shifting all elements by one position forward, and then at the end you are inserting the appropriate element. It is at its desired position. Okay, so this is basically step of insertion. I am again saying, आप लोग पहले I को एक लोकेशन पे प्लेस कर रहे हो. ओके, उसके बाद यू आर इटरेटिंग बैकवर्ड्स. ओके, you are iterating backwards, and you are checking if the elements previously are greater than the current element. If yes, you are shifting or pushing all the greater elements in front, okay, because as they are greater than our current element, and then at the end once all the pushing is done, okay, so this is basically step of pushing, okay, you are pushing all the elements one step forward, and then सबसे लास्ट में आप करंट एलिमेंट, ठीक है, सब पुशिंग हो जाने के बाद करंट एलिमेंट की जो डिजायर्ड लोकेशन है वहां पे आप उसको डाल रहे हो. So there are two things which are taking simultaneously. One, pushing of larger elements at front, pushing of larger elements at front, and number two, pushing pushing the current element which is smaller than the previous element at its desired location. Okay. So again, I plus plus, current will be equal to ARR of I. So current will have value 3. Okay, current will have value 3, and previous plus plus. Previous is equal to I minus 1. So previous is equal to I minus 1. Now again, compare. Previous is greater than equal to 0. True. ARR of previous is greater than current. ARR of previous is greater than current. Correct. So what we will do? ARR of previous plus 1 is equal to ARR of previous. So ARR of previous plus 1 means here we need ARR of previous. So 5 will come here. Okay, done. Then what? Previous minus minus. Then again check if ARR of previous is greater than ARR of current, that is 3. So yes, it is. Yes, it is. So what? ARR of previous plus 1 is equal to ARR of previous. So previous plus 1 में जाएगी ARR की वैल्यू. ओके, करेक्ट. सो एज यू कैन सी हमने कैसे ग्रेटर एलिमेंट्स को पहले आगे पुश किया. ओके, देन अगेन प्रीवियस माइनस माइनस. सो प्रीवियस ग्रेटर देन और इक्वल टू 0. ट्रू. But this time ARR of previous, okay, ARR of previous is what? 1 is not greater than ARR of current because current is having value 3. Current is having value 3. Okay. So the loop will not be executed even though this condition is true. This condition is not true. So loop will break, and then ARR of previous plus 1. So if previous is here, then previous plus 1 will be here. This will be updated with value current. So आप लोगों ने देखा कैसे पहले ग्रेटर एलिमेंट्स को हमने आगे पुश किया, एंड फिर जैसे ही हमें वो डिजायर्ड लोकेशन मिली, ओके, जैसे ही हमें वो डिजायर्ड लोकेशन मिली हमने वहां पे करंट को इंसर्ट कर दिया, एंड हेंस द नेम इंसर्शन सॉर्ट. देन लास्ट I प्लस प्लस, ठीक है, करंट इज इक्वल टू C एंड प्रीवियस इज इक्वल टू I minus 1. Previous is equal to I minus 1. So current will now have value 2. Current value in current will be 2. I is this and previous is I minus 1. And again same process. Previous greater than or equal to 0. Correct. ARR of previous is greater than current. Current में value है 2. ARR of previous में value है 5. So yes, it is. So what we'll do? ARR of previous plus 1 is equal to ARR of previous. So 5 will come here. Okay. Then previous minus minus. Now again check. ARR of previous is greater than current, and previous is greater than 0. Agreed. So both the conditions are satisfied. So previous plus 1 is equal to ARR of previous. So 4 will come here now. So ऑब्जर्व करो. ओके, ऑब्जर्व करते चलो कैसे ये लार्जर एलिमेंट्स आगे पुश होते जा रहे हैं. कैसे ये लार्जर एलिमेंट्स आगे पुश होते जा रहे हैं. नाउ अगेन प्रीवियस माइनस माइनस, नाउ अगेन प्रीवियस माइनस माइनस. नाउ चेक, previous greater than or equal to 0, correct. ARR of previous is greater than current, ARR of previous is greater than current, satisfied, both the conditions are satisfied. So what we will do, ARR of previous plus 1 is equal to ARR of previous, so 3 will come here. So देखा आपने कैसे पहले यहाँ पे 4 था, यहाँ पे इनिशियली 5 था एंड यहाँ पे इनिशियली 2 था, एंड कैसे हमने उनको एक एक आगे पुश किया. सो नाउ 5 will come here, 4 has come here, 3 has come here, okay. And now again at the end previous minus minus, and now what, previous greater than 0 is true, but ARR of previous greater than current is not true, so the loop will not be executed and the loop will break, and ARR of previous plus 1 is equal to current. So previous plus 1 is this, 1 2 3 4 will be updated with current, and current has value 2. So 1 2 3 4 5, and this is how the variables have been sorted. I suggest you, if you haven't understood anything, please rewatch, because this is something जो आपको शायद एक बार में ना समझे, okay, which you would not understand in the first try or the first go, okay. So it's completely normal, it's completely okay if you have not understood this in the first go or in the first try, okay. It's a little bit tricky, but yes, it is easy to understand. All you need to know is how the elements are pushed, the larger elements are pushed forward, and then as soon as we find an appropriate position, okay, as soon as we find an appropriate position, how we perform the insertion. So one is the step of pushing and another is the step of insertion, and it's completely normal. If you have not understood this in the first try, I suggest you can rewind and watch the all steps once again, okay. And I hope you guys are making notes simultaneously, because I think your notes are something which are going to help you at the end. So let's just code it now. So public class main, public class main, PSVM, uh, let's just define an array 5 4 1 3 2. Then let's just print it before sorting, array before sorting. Then what we will do, I think it's simple. All uh, we will do is just a for each loop, this out x, okay, this out, then call the insertion sort, and our array will go as a parameter in it, and the returned updated array will be stored again, okay. And simply just, so array after sorting, and just print it. Now most important thing, our actual logic. So static, because we will are returning an array, so return type of this insertion sort function will be also an array, insertion sort, and our array will go as a input parameter to it, correct. Now what, Now simple. I will start from first index, that is second position. So int I is equal to 1. So in the previous videos, whenever we used to write some loops, we used to write for int I is equal to 0. That was because we are starting from 0th index, that is first position. But this time we are starting from first index, that is second position. I less than dot length I plus plus. Then current variable, current is equal to arr of I, and previous is equal to I minus 1. Then while previous is greater than equal to 0 and arr of previous is greater than current. If this is the case, we need to do is arr of previous plus 1 is equal to arr of previous, correct? And lastly, previous minus minus. And one last step in the outer loop would be arr of previous plus 1 is equal to current, and return the modified array. Perfect. uh, so current variable, this is previous variable, then this is step of pushing, update statement. So common, very common in while loops. So in every while loop, you basically at the end and necessarily write this previous statement. Okay, and this is the step of insertion. uh, I think we must not get any errors, but let's just try running it. Okay, perfect. So it's running absolutely correct. 54132 before sorting, 12345 after sorting. So this was the complete code. If you want, you can take a screenshot of it. um, a little bit tricky to understand, but you can watch it again and understand it again. It's okay if you have not understood it in the first try, but it's easy. Believe me, you will get it and understand it in the second or third try. Okay. Only thing to remember is how these three variables I, current, and previous are working. If you are able to play with these three variables, I, current, and previous, if you are able to play with these three variables, you can easily code insertion sort at any time. All you need to remember is how this while loop is working and when to do step of pushing and when to do step of insertion. So the larger elements are pushed forward every time, and as soon as we find an appropriate position, we insert the current element. So this was it. If you want, you can take a screenshot of this code. uh, I hope you have understood it. If not, you can anytime rewatch again. Please practice this, because this is a little bit tricky to understand. And if you are satisfied and think that I have contributed enough to your logic building, please do consider subscribing and sharing and liking this video. And thank you everyone for watching till end, and I will see you in the next one.